electrical circuit. Don't forget to like and subscribe.
Alternating voltage and current. Discuss an alternating current. Difference between alternating current and direct current. DC current versus AC current. DC flows in one direction in the circuit. Alternating current, AC, flows first in one direction, then in the opposite direction. The same definition applies to this AC voltage. DC voltage has a fixed polarity, while AC voltage switch polarity back and forth. Why AC is used in preference to DC? Electricity is produced by generators at power stations and then distributed by vast network of transmission lines called the national grid systems to industry for domestic use. Since its voltage can be readily altered using transformers. Wherever DC is needed to preference two AC devices called rectifiers are used for conversion.
Why not dispense entirely with AC and just use DC for everything?
Easier and cheaper to generate AC than DC, and AC is more conveniently distributed than DC. Source of AC. Alternating voltage and current will be generated with the electromagnetic induction principle. At the most basic level, a simple electrical generator as simple as principle below. Conductor is moving, magnetic flux is static. Second, magnetic flux is moving, conductor is static. Generation of an AC. Faraday's laws and Lenz's laws. Faraday's laws state that an EMF is induced in a conductor when the magnetic fields around it change. The EMF is given by the rate of change of the magnetic flux. Lenz's law states that the direction of the current induced in a conductor by changing magnetic fields that induce current oppose the initial changing magnetic field. The current induced in a circuit due to a change or a motion in a magnetic field is so directed as to oppose the change in flux and to exert a mechanical force opposing the motion. Current waveforms produced. One loop and two pole magnet. Figure shows a suspended loop of wire conductor being rotated, moved in a clockwise direction through a magnetic field between the pole of a permanent magnet. For ease of explanation, the loop has been divided into a dark half and light half. Notice in A of the figure that the dark half is moving along parallel to the lines of force. Consequently, there is no cutting lines of force. The same is true of the light half, which is moving in the opposite direction. Since the conductor are cutting no lines of force, no EMF is induced. As the loop rotates towards the position shown in B, it cuts more and more lines of force per second, inducing an ever-increasing voltage because it is cutting more directly across the field line of force. At B, the conductor is shown completing 1/4 of a complete revolution, or 90 degrees, of a complete circle. Because the conductor is now cutting directly across the field, the voltage induced in the conductor is maximum when the value of induced voltage at various points during the rotation from A to B is plotted on a graph, and the points connected the curve appears as shown below. Current waveform produced. First, similar as sine wave. Second, it is produced by certain type of electronic oscillator when it is operating from its battery. Third, the sine wave is unique in that it represents energy entirely concentrated at single frequency. Of sinusoidal waveform. It is taken from Faraday's law equation, and when the loop angle 90 degrees where theta equal to 90 degrees, so sin theta equal for 1, then EMF is maximum. So so it equal to En. From equation 1, there are 4 alternating voltage where we get some equation that show below. Also same from the alternating current that show below. So from instant we should write the equation based on the what we show at the side. The various voltage and current value of a sine wave. Instantaneous current and voltage, it will reference to the slide. Next slide. Root mean square RMS voltage. RMS voltage is the amount of DC voltage that is required for producing the same amount of power as the AC waveform. The RMS voltage of sinusoidal waveform is equal to 0.707 times its peak value. VRMS same is equal to the same value 0.707 volt. AC levels are assumed to be expressed as RMS value unless clearly specified otherwise. Calculation of root mean square value for a sinusoidal variable shown at the next slide. Average voltage is the average value of all the values from 1/2 cycle of the waveform. The average voltage of sinusoidal waveform is equal to 0.637 times its peak value, same as volt equal to 0.6374 volt. Calculation of average volume for a sinus variable will show at the next slide. From factor Kf, the form factor for a sine wave is defined as the RMS value or average value. Peak factor or cheese factor, known as Ka, the peak of crest value of sine wave is defined as the maximum value or the RMS value. Note for student, the RMS value is always greater than the average value, except for a rectangular waveform, in which case the heating effect remains constant, so that the average and the RMS value are same.
When of a sine wave, the sinusoidal AC waveform. The most common AC waveform is a sinusoidal waveform. The sine waveform is accurately represented by the sine function of the plane trigonometry in the box. Equation by the sinusoidal AC waveform. Y equal R sin delta, where Y equal the instantaneous amplitude, R equal the maximum amplitude, delta equal the horizontal displacement, and then the vertical axis represent the amplitude of the AC current or voltage. In impulse of or volts, the horizontal axis represent the angular displacement of the waveform. The unit can be degree or radian. The radian is the standard unit or angular measure used in many areas of mathematics. It describes the plane and angle subtended by a circular ARC as the length of the ARC divided by the radius of the ARC. The unit was formerly a SI supplementary unit by the but this category was abolished in 1995, and the radian is now considered a SI derivative unit. The SI unit of solid angle measurement is the statute radian. Conversion between radian and degree. It stated 1 radian is equal to 180 over pi degrees. Thus, to convert from radian to degrees, multiply by 118 over pi. Degree equal radian multiply 118 over pi. Conversely, to convert from degrees to radian, multiply by pi over 180. Radian equal degree multiply pi over 180. The phase angle of a sine wave. If two sine waves have the same frequency and occur at the same time, they are said to be in phase. On the other hand, if the two waves occur a different time, they are said to be out of phase. When this happens, the difference in phase can be measured in degree and is called the phase angle delta. As you can see, the two waves in part B are quarter cycle out of phase. So that phase angle delta equal 19.
Use a phasor to represent a sine wave. Define phasor. A phasor is a constant complex number representing the complex amplitude, bracket, magnitude, and phase of a sinusoidal function of time. A phone vector phasor is a representation of a sine wave whose amplitude over a bracket a phase bracket theta and frequency at time invariant. How a phasor relates to a sine wave. A phasor is a straight line drawn in a such way that is related to the amplitude of the sine wave represented and its angular position relative to other phasor. Is related to other phasor differences between the quantities. Second, the relationship between a phasor and a single sine wave is illustrated in figure. The phasor represented by the arrow is the rotating in the anti-clockwise direction about the center origin point, describing the sine wave as it rotates. Next, phasor diagram. In AC electrical theory, every power source supplies a voltage that is either a sine wave of one particular frequency or can be considered as a sum of the sine wave of differing frequencies. The net thing about a sine wave such as V over T equal A sin, A capital letters, and then A sin over WT plus S is that it can be considered to be directly related to a vector of like revolving in a circle with angular velocity. In fact, just the y component of the vector. Since a pen and paper drawing cannot be animated so easily, A, a 2D drawing of a rotating vector show the vector inscribed in the center of a circle as indicated. The angular frequency may or may not be indicated. Sinusoidal waveform. The phasor diagram is drawn corresponding time 0 bracket time equals 0 on the horizontal axis. The length of the phasor are proportional to the value of the voltage bracket V and the current bracket I. And the instant in time that the phasor diagram is drawn, the current phasor lags the voltage phasor by the angle as the two phasors rotate in an anticlockwise direction as started early. Therefore, the angle is also measured in the same anticlockwise direction. Define angular velocity. Angular velocity, also called rotational velocity, is a quantitative expression of the amount of rotation that a spinning object undergoes per unit time. Basic circuit law of resistive AC circuit. Ohm's law to resistive circuit with AC source. Ohm's law states the current through the conductor between 2 points is directly proportional to the potential differences or voltage across to the 2 points, and inversely proportional to the resistance between them. Ohm's law for resistor. A resistor has no time delay and therefore doesn't change the phase or signal. Therefore, V equal IR remains valid. Ohm's law for resistor, inductor and capacitor. V equal IZ, where is Z is the complex impedance. Kirchhoff voltage law and current law. Kirchhoff current law state the algebra sum of the current in all the brackets which converge in a common node is equal to 0. Kirchhoff voltage law state the algebra sum of the voltage between successive nodes in a closed path in the network is equal to 0. Power in AC resistive circuit. The power formula indicates that P equal I V. The only distinction with DC circuit is that here it must be not where there is a peak value of power bracket in the current and voltage are peak value, or if it is a RMS value of power bracket in the case both current and voltage are RMS value.
Alternative voltage. Kadat.
Situ tak ada.
Ah,
Situ
ya lah
saya
sudah
dah.
situ kredit kepada.
Why?